Alright, welcome back to another video. This one is on finding missing angles within a parallelogram. As you see, I've drawn out a parallelogram. It is parallelogram ABCD. I have an angle measure 15 degrees on this angle A. This would be angle DAC. I have 15 degrees. I also have another angle that is measured for us. It is angle ABC. So I have an 80 and a 15 degree angle. Now what we've learned in class and what you will continue to probably work on at home is that with parallelograms we understand that in total we have 360 degrees. Don't jump the gun this time. Here we go. 360 degrees in a parallelogram. Now there's some things that we know about a parallelogram. We know that we will have sides. They'll be opposite, that will be parallel, like DC will be parallel to AB. And we will also have side AD parallel to side BC. Knowing that they're parallel, they will share some common traits here, meaning that this angle B, which I will put in green, will have the same measure angle as angle D and those opposite angles. If we think back to isosceles triangles, it's the same concept. I will also understand that this angle A up here is the same as this angle C. Now as you can see, I'm wanting to know a lot of different angle measures. I'm going to want to measure angle ADC, angle DCA, angle ACB, and angle BAC. Now before you freak out, if you remember back, when we see something like this, we need to focus just on the vertex, meaning our middle letter of this angle. So I'm actually finding angle D on angle ADC. But before I even get to that, I need to do some things ahead of time. Knowing that this angle B is 80 degrees and it will share the same quality as angle D, I'm going to go ahead and mark that this is 80 degrees for angle D. Now I have something that I can easily work with. If I look at my parallelogram as a whole, I see a parallelogram. But I see that it has a line segment cutting through it. If I happen to do this, all of a sudden, what do I see?
A triangle.
A triangle. And your great teachers that you have in your room each day have taught you that a triangle has
180 degrees.
180 degrees. So I need to remember I have 180 degrees. So far I have 80 and 15, and 80 plus 15 will yield me 95 degrees. I must find this other angle that's missing. So I do a quick little subtraction. And I will get 85 degrees at that angle. Now, I take a look at what I have here. Something else that you've learned from class is this. I've got these alternate interior angles here. I have 15. And this triangle is congruent to this triangle right here. So if I've got 80 here and I've got 80 here, it seems relative for me to say that I'm going to end up having 15 degrees here and 85 degrees here. Notice how they're opposite one another. Now I can go back and answer my questions. If I'm looking for angle ADC, I start with A, I go to D, and I go to C, and I see that my vertex will yield me 80 degrees. I move to my next one, DCA. Start at D, go to C, go up to A. I see that because I'm following this, I will actually be looking at this angle of 85 degrees. My angle ACB, A down to C, then back up to B. I'm looking on the inside this time. This will be 15 degrees. And I will end with angle BAC. BAC. If I follow it, I'm looking actually for this angle, which would be another 85 degrees. Now this is for